2.1 is called linear equations, and they are linear because there are no exponents on the variables. So if you see an x or a y, they're not going to be x squared or y squared, just first power. And they're going to ask you to solve these. And the solution is the number that makes it true. So when they ask you to solve, if you see something like this, you're just going to see basic equations. We'll give you a simple one to start with. And the directions say solve. What they want you to do is figure out what x should be, what number x is, so that this will be true. And you might be able to look at that and figure it out. But when it gets harder, the way that we'll do this is just get x alone. And anything you do is legal as long as you do it to both sides of the equal sign. So the general rule is to do the furthest thing from x. So instead of worrying about the 2, I'm going to worry about the 5 first. And since I'm adding the 5, if I want to get rid of it, I need to subtract it. We do the opposite operation. So 5 subtract 5 is 0, so it's gone. But over here I have 9 subtract 5, which is 4. Now I'm to my 2x, and so to get x alone, I have to get rid of 2. And we're multiplying, right? This means 2 times x equals 4. So the opposite operation of multiply is divide. So to get rid of that 2, I will divide by 2 on both sides. And of course, again, it's legal as long as you do it to both sides of that equal sign. And 2 divided by 2 is 1, so I just have 1x, and 4 divided by 2 is 2. Now, I would suggest that you check these at the beginning just to make sure, and so that when you're on a test, you can check it and know that you're right. And to check it, all you have to do is plug it back into your original equation, 4x, and see if it is true. And we see that, oh, that gives us 4 plus 5, and yes, that's true. That does equal 9. So we know that our answer is right. All right, let's try a little bit harder one. What if they give you negative 4x minus 1 plus 5x equals 9x plus 3 minus 7x. So now we have a whole bunch of x's, and we still need to figure out, since they're all called x, they're the same number. So one number we'll put into to all those x's, and it will make it true if it's the right number. So what you do when there's more than one x is combine them. So if I'm on this side of the equal sign, I'll just add negative 4x and 5x, which gives me 1x. And you can write 1x, or you can just write x. And if you just see an x, like we see right here, this means 1x. Alright, and right here I'm going to combine the 9x and the negative 7x. So I now have 2x plus 3. Alright, now I have the x on both sides of my equal sign. So I want to get those on the same side. And it doesn't matter which side you take them to, but you want to get your x's together and everything else on the other side. So let's say that I choose to subtract 2x. And you can subtract 1x if that's easier as well. Right here I know 2x subtract 2x is 0. And I have 1 subtract 2x, which is negative 1x. And I still have that subtract 1, and I still have that 3. So now to get x alone, we need to do the opposite operation. The furthest thing from x is this subtract 1. So I'm going to do the opposite. I'm going to add 1 to both sides of the equal sign. So negative 1 and positive 1, those are gone. And I now have negative x equals 4. But we still aren't done, because we don't want to know what negative x is. We want to know what x is. And so I have to get rid of that. And that's the same as multiplying by negative 1. So to get rid of it, I will divide by negative 1. And so a negative divided by a negative becomes positive, and then I have 4 divided by negative 1, which is negative 4. Now this one would be a much longer one to check, but you could absolutely plug in negative 4 right here, 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 and here, and prove to yourself that it's true. And it might be worth it so that you can do it on a test. Okay, let's go to another problem. How about this one? Negative 4 times 5x minus 5 equals negative 3 times x minus 4. Now, this is the first time we've seen these parentheses in the problem. And since we know that parentheses mean you do this first, but I can't, because I can't combine 5x and subtract 5 because they are not like terms. So we can't combine them. So what we do to get them out of the parentheses is that word we all love, distribute. We're going to distribute, which means that I'm going to take this -4 and I'm going to multiply it by the 5 and by the -5. And I chose a negative because there are lots of mistakes when I ask students to distribute negatives, because you have to make sure you remember that negative when you distribute it all the way through. So -4 times 5 is -20x, and -4 times -5 is now +20. And so don't forget that. Same thing over here. I'm going to go -3 times x, which is -3x, and then I'm going to go -3 times -4, which is +12. Now, once again, I need to get my x's together and my numbers together. And last time I took my x's over here. So just to show you that it works both ways, I'm going to take my x's to the right side. And so we're going to take this 20 over there. I'm going to add 20x to both sides. And put it by the x because you're going to combine like terms. Right here, -20 and +20 cancel, so that's gone. And I have 20 equals 17x plus 12. And that's because I added those. Now that x is on this side, I do the furthest thing from x. I'm going to subtract 12 from both sides. So I now have 8 equals 17x, and the 12 is gone. And we're almost done. The last thing we need to do is divide by 17. So my answer is 8/17. And that's kind of a tricky one to check because you have to subtract fractions, and so it's kind of yucky, but just do enough that you could do it on the test. Alright, how about this one? This is a fraction, and I just have this, and then I have two special cases. So this is a y, sorry. And when you see fractions like this, I'm going to recommend you do this the whole semester. If I need to deal with an equation with fractions, as long as I have an equal sign, it's legal to just get rid of those fractions. And the way that you do that is you look at all of them, every denominator on both sides of the equal sign, and say, what's the smallest thing that 3, 4, and 6 will all go into? And you probably know it's 12, right? So what I'm going to do, just like I can subtract something from both sides or add something to both sides of the equal sign, you can multiply. And right here we even divided both sides of the equal sign. Well, here we're going to multiply, and as long as I do it on both sides of the equal sign, it's legal. So I'm going to multiply by 12, and I'm going to do it to this whole side, and I'm going to multiply this by 12 too. So in the future, instead of writing it like this, what I'll do is I'll write it like this by each one. And that we know is the same as distributing that 12 through, but it'll be just a hair shorter writing in the future. So that allows me then to reduce, and when I reduce, all my denominators will be gone. I will no longer have to deal with fractions. So now I have 4 times y minus 3 times y equals 2 times 1. 4y subtract 3y is 1y, and I'm done, equals 2. Alright, now these, I just have 2 more, and they're the same kind of stuff, but the difference is that now they are unique situations. So they're worth writing in your notes. If you think you're done listening, hang in there for a second longer. So this is still 2.1. We're going to do these two problems. 3x plus 5 equals 3 times x plus 2. And this one, 6x minus 4 equals 2 plus 6 times x minus 1. And let me show you these unique ones. And this rule will hold true the whole rest of the semester, what you learn right here today in the first section. So we're going to begin by distributing just like we did before. So I have 3 times x and 3 times 2. And nothing on this side changes. But now look what happens if I try to get my x's together. if I try to get my x's together, they both are gone, aren't they? 3x minus 3x is 0, 3x minus 3x is 0. So what I'm left with is no variable to solve for. When that's the case, if your variable cancels, you look at what's left and say, does 5 equal 6? And we know that it does not equal 6. So if it is not true, the answer is no solution. And MyMathLab and most books write that with a symbol that looks like that. That means no solution. That's straight, no solution. Now this one, let's go ahead on the right and distribute this 6x all the way through the parentheses. And then I'll go one more step and combine like terms. So I'm going to combine 2 and negative 6. Now look what happens here. If I try to get my x's together, I'll subtract 6x from both sides, and once again my variable is gone. But now I have negative 4 equals negative 4. And possibly you would try to get the numbers together first. So you might even have added 4 to both sides, and you might have 0 equals 0. And either way, whether you have that or whether you have that, you don't have a variable. There's no x in the problem, but it's true. 0 does equal 0. Negative 4 does equal 4. So now our answer is all real numbers. That means any number that you put in right here and here, I could put 2 there and there, I could put 10 there and there, whatever I choose, it'll work. And the way the symbol for that is a double thick R, like that. So when you see that in MyMathLab, that means all real numbers. Okay? Alright, first section learned. You guys are awesome. Hang in there.